finished up relations the other day, that leads us into functions. Because our relations are functions, except functions deal with inputs and outputs. And you probably remember in elementary school, you had some function machines in math, right? When you had an input, it gave you an output. That's kind of what this is in a way. It's a relationship between input and output. Our key here is each input has exactly one output. Okay, that's what makes a function a function. Each input has exactly one output. So each number that gets put in, or each x value, which is our inputs in our graphs, or each domain are also our inputs, can only have one output, can only output one number to be a function. So by looking at my mapping here on the left, I got my mapping here. The domains, or my x values, those are our x values, each one can only have one output. So for example, -2 has one output of -3. 0 has one output of -3. They go to the same output, but that's okay as long as each input has exactly one output. 3 outputs to 6 and 4 outputs to 9. And our range, those would be our y values. Okay, our outputs are our ranges, and those are our y values. Well, let's determine whether each relation is a function. Explain. Well, to explain, in order to be a function, each input has to have one output. So, output. Remember, inputs are domains and x's. Outputs is nice word. Outputs are our range or our y values. So I look here at my first example, this mapping. Each input, so -2, 0, 2, and 4, has exactly one output. So I would say, yes, this is a function. And to explain it, all I have to do is say each input has exactly one output. That's the only thing that makes a function a function. Each input has exactly one output. That's all I got to state. Well, looking at 2, if I notice -7 here, these are inputs, right? Has two different outputs. It has an output of 8, and it also has an output of 4. So that is not a function because -7 has two outputs. So each input can only have exactly one output. That's important. And we also have two different types of functions, discrete and continuous. It's pretty straightforward. Discrete, that means dots are not connected, right? So I can just draw a bunch of dots. Yeah, that's discrete. It doesn't continue. Continuous means it goes on. So it could be a straight line. Continuous, that's a continuous function. It could look something like this, continuous. Okay, it's got arrows at the end to show that it's smooth or curved, and it goes on. It continues. Right, and we also have something that we call the vertical line test to see if something is a function or not. So I'm going to draw 3 lines here. Here's a graph. Here's a graph. And let's go with, here's a graph. So my vertical line test, we use it to see if a graph is a function. Well, if each input or each x value can only have one output, one y value, to make it a function, we can use a vertical line. So my vertical line can only cross the graph once. Each vertical line that I draw can only cross my graph once for it to be a function. So if I look at this first one, if I draw a vertical line anywhere I want, it crosses my graph one time. Let's draw a line here, crosses my graph once. Line here, crosses my graph once. This would be a function. Because each input, each x value, as I move along my x values, has exactly one output, one y value. Same thing with 2. Anywhere I draw a vertical line, crosses my graph once. Cross my graph once. Cross my graph once. So this would also be a function. Just use that vertical line test. Whereas if I come down here, boom, vertical line. It crosses my graph twice. So this x value, which is about at 3-ish here, right? It crosses my graph twice at about 3, 3, and about 3, -2. So that has two outputs. The input 3 has two outputs. So this would not be a function. So my vertical line test, as long as it crosses only once, it's a function. Well, let's take an example here. It says there are 3 lunch periods at a school. During the first period, 352 students eat. Second period, 304. And third, 391. It says make a table and determine domain and range. Well, domain and range, that's really our x and our y's, right? So you can just state that. Just tell me that your domain, right, goes with your x. Your range goes with your y. And if we look, domains, they got to be our periods. Those are coming first. Okay, as we move up in our periods, the y gets affected. So I have periods 1, 2, and 3. Period 1, we had 352. Period 2, we had 304. And period 3, we had 391. It says write the data as a set of ordered pairs, then graph. Well, I already got my table. So 1, 352, here's an ordered pair. 2, 304, here's another ordered pair. And 3, 391. So here's my relation. There's my relation. And then we graph it. Well, I don't need an entire coordinate plane. I could just use an L graph because I'm just working with positive numbers. And down here, I could just go 1, 2, 3, count them up. Over here, we're working just in the 300s. So let's maybe count this just a little bit differently. Remember, if I want to jump, so right here is 0, 0. If I want to jump up a little bit, I could put a little break in the graph. And I could maybe start it right at 300 here. And I can go 325, 350, 375. Go by 25s. And then just go ahead and graph. 1, 352, so somewhere about there. 2, 304, a little lower. 3, 391, it's getting up closer to 400. And there we go. I'm not connecting anything. It's a discrete graph. That's all I do. Put my ordered pairs and graph. Don't have to do anything else with it. Pretty straightforward. What about this? Determine whether x equals -2 represents a function. Well, does each input have an output? Well, 2 ways to check this. One, I can make a table and see any number I put in for x to see if it has exactly one output. Or I could graph it. We're going to do both here. Well, you kind of need your table to graph with it in this case, or you could use my shortcut we're going to go through. But when I make a table, I just pick any x values I want. So I'm going to pick 0, 1, 2, and 3. And I'm going to plug these in. Well, if I plug in 0 right away, 0 equals -2. That doesn't even make any sense. So I can't even pick 0, 1, 2, and 3. What's the only x value that'll work here? Well, -2, right? -2 is the only thing I can plug into that equation to make that work. Well, if I plug in -2, it doesn't really matter what my y is, does it? I could have -2, 0. I could have -2, 1, -2, 2. So is this going to be a function? Each input has exactly one output. Well, the input of -2 has 3 different outputs, doesn't it? It has an infinite number of outputs. I could go -2, 12. It just goes on forever. So this is not a function. And if I graph this, here's my quick trick to graph. I just go to -2 on the x-axis, which is right here, and I draw my vertical line in. I don't want to draw horizontal because that's right on my x-axis. That doesn't make any sense. And if I look at the points, -2, 0, right here, -2, 1, -2, 2. Okay, so that's how I come up with that. And if I draw a vertical line, well, the only vertical line I could draw is right here to be on my graph. Well, it crosses my graph a ton of different places forever. So it doesn't pass the vertical line test, so I know it is not a function. Okay, you have function notation. You've been seeing equations with y before. So for example, something like this, when we've been working with things on a coordinate plane. Well, now we're going to use function notation instead of having y for our output. So we're basically going to replace y with f of x. And we read that as a function of x. So instead of having this y, I'm going to replace it with f of x. A function of x, where x is my input. okay, and I get an output for my function. That's all that really happens. And we're going to put some things inside of here to figure out what I get for an output depending on the input. So let's see how we use this here. So for f of x equals 3x minus 4, or a function of x equals 3x minus 4, find each value. Well, if we notice, I'm saying a function of x, well, we're going to replace x with 4 in this case. So a function of 4 when 3x minus 4. So all I'm doing is I'm plugging in that 4 for x. So I'm plugging in this 4 for x. And then we go through our math. 3 times 4 is 12. 12 minus 4 is 8. So I would say my function when x is 4 equals 8. So I'm inputting 4 and I'm outputting 8 in that function. You just plug in the number for x, or whatever you're given it. So in this case, same thing. My function f, well, there's my function up top for f, 3x minus 4, and I'm plugging in negative 5 for x. So 3 times negative 5 minus 4, and we get negative 15 minus 4, and I like to add the opposite. So negative 15 and a negative 4 gives me negative 19. So I would say my function when x is negative 5 equals negative 19. We're just plugging in and solving. So when the input is negative 5, the output is negative 19. Could get a little more confusing in here. Now I'm calling my function h, and I'm saying function h of t. So my input is t, my output is the function h of t, and I have 1248 minus 160t plus 16t squared. Now find the value. Well, now it's saying, here's my function h, and I'm going to replace 2m with t, right? Because here's my t. I'm just placing 2m in for t now. So let me write out my equation here. My function, 1248 minus 160t plus 16t squared. So now if you look, I'm replacing 2m into t. So we rewrite this 1248 minus 160, well, t, but I'm replacing it with 2m plus 16, replacing that with 2m squared. Now we follow our order of operations here. So 2m squared is going to 2m times 2m, which is really 4m squared. And 16 times 4 gives me 64m squared. And now I have to keep multiplying before I can add and subtract. So 160 times 2m gives me 320m. And bring down my 1248 minus right there. So I'm saying h, my function h, when I replace t with 2m, gives me that. And I can't combine anything else. These are not like terms. So I'm done. You're just simplifying it as far as you can go given the function. So just plug in whatever the input is into your value. It could be an x, could be a t, it could use any variable, right? You just follow the function rule. All right, there's a little bit on functions, and there's your assignment.